Imagine a world just waking up to science. This was the world of Galileo Galilei. Born in Pisa, Italy in 1564, a time of great change. His father, Vincenzo, was a famous musician who understood patterns in music. Perhaps young Galileo learned to see the world this way too. Galileo's family hoped he would study medicine, a safe path. So he went to the University of Pisa but was drawn to mathematics and physics. He saw a chandelier swinging in a cathedral and timed its swings with his pulse. He noticed the time for each swing was the same, big or small. This was the beginning of his scientific journey. He didn't just accept what old books said, he wanted to experiment and measure. He eventually left the university without a degree in medicine. His passion for mathematics was too strong. He started teaching and inventing practical devices. He studied how objects fall and move, laying the groundwork for a new understanding of the universe. Little did he know his biggest discoveries were still ahead, waiting in the stars. Galileo was a keen observer, always questioning. He wanted to see for himself, to experiment, to measure. This way of thinking was new and revolutionary. Then came news of a curious invention from Holland, a spyglass. Galileo saw more than a toy. He understood its potential. He started grinding his own lenses and made his own telescopes. Most people used early telescopes to spot ships or see enemy armies. Galileo did something different. He pointed his telescope towards the night sky. The heavens revealed secrets. He became a messenger from the stars. He looked at the moon and saw mountains, valleys, and craters. Then he turned his gaze to Jupiter and saw 4 tiny points of light orbiting it. These were Jupiter's moons, showing that not everything circled the Earth. He also saw that the Milky Way was made of countless individual stars. He observed the phases of Venus just like our moon's phases. This could only happen if Venus orbited the Sun, not the Earth. The evidence was piling up. A cosmic revolution was brewing. Galileo's telescopic revelations opened up the universe. He showed us that we could understand the cosmos through reason. His discoveries were groundbreaking, challenging old ways of thinking. The heavens were no longer distant and mysterious. They were within reach. Galileo's observations supported an old idea by Nicolaus Copernicus. Copernicus suggested that the Sun, not the Earth, was the center. This is called heliocentrism. In Galileo's time, most people believed in geocentrism. The Earth was the unmoving center of everything. Galileo's findings fit heliocentrism perfectly, so Galileo began to champion the Copernican view. He wrote about it and taught it, challenging powerful institutions. The Catholic Church held immense power in Europe. Its teachings were based on an Earth-centered universe. To suggest the Earth moved was seen as heresy. Galileo, a devout Catholic, believed science and religion could coexist. He famously said, "The Bible tells us how to go to heaven, not how the heavens go," but the authorities did not agree with his approach. He was warned to stop teaching heliocentrism as a fact. Galileo, convinced by his observations, found this difficult. He believed what he saw with his own eyes. The truth of the cosmos was written in the language of mathematics and observation. His ideas were stirring up too much trouble. Galileo did more than just look at the stars. He changed how we ask questions about the natural world. Before him, science often relied on ancient texts. People would quote Aristotle as the final word. Galileo insisted on testing ideas. He urged that we observe, measure, and then conclude. This approach is the heart of the scientific method. You form a hypothesis, a testable idea. Then you design experiments to check if it's true. You collect data, you analyze it. If the evidence supports your hypothesis, great. If not, you change your hypothesis and test again. This cycle of observation, hypothesis, and testing drives scientific progress. Galileo conducted careful experiments with rolling balls on inclined planes. These experiments allowed him to measure time and distance accurately. He discovered laws of motion and showed that the acceleration of falling objects is constant. He used mathematics to describe these physical phenomena. His work laid a critical foundation for Isaac Newton, who came later. Galileo's approach transformed how science was done. Despite his groundbreaking work, Galileo faced immense pressure. In 1632, he published his dialogue concerning the two chief world systems. It compared the Earth-centered and Sun-centered models. Though presented as a debate, it clearly favored Copernicus. He was summoned to Rome to face the Inquisition. In 1633, Galileo was found vehemently suspect of heresy. He was forced to recant, to publicly deny the heliocentric view. Legend says he muttered, "Eppur si muove," meaning, "and yet it moves." He was sentenced to house arrest for the rest of his life. He spent his final years blind but still working, still thinking. Galileo died in 1642, the same year Isaac Newton was born. His struggles highlight the conflict between new knowledge and old dogma. His methods and discoveries could not be suppressed forever. Galileo is rightly called the father of observational astronomy and modern science. His courage to question, to explore, to seek truth inspires us still. He taught us to look at the evidence, even if it's uncomfortable. His life reminds us that science is a journey of discovery. Galileo's light, the light of reason and inquiry, continues to shine brightly.